This is Algebra 1B, Day 3, Lesson 1.3, Solving Systems of Equations by Elimination. In the previous lesson, you learned how to solve systems by graphing, but we can't find out what the values of x and y are of two equations with two unknowns by just looking at their equations without the graph. Before we practice some actual problems, I want you to flip your paper over to the back and we're going to take some handwritten notes. So the steps to solving systems of equations by elimination. Well, our first step is that both equations must be written in the same form. Otherwise, you need to convert. So when we talk about the forms of equations, there's two forms that we've been mainly working with. There is a third one too. But the two forms that you often see, so here's an example, 2x plus 3y equals 4. Do you remember what type of form that's called? When you have your x and y variable before your equal sign, equaling your constant, that's called standard form. Here's another equation, y equals 5x plus 6. Okay. You should recognize this by now. This is slope-intercept form. Because these two equations are not in the same form, you need to change one into the other. It does not matter which one, but generally when you're working with systems of equations, you'll see in textbooks and all, they usually always actually convert it to standard form. So let's take that slope-intercept form equation and we're going to convert it to slope-intercept form. So I do this, I just draw an arrow to show that I'm going to convert it. And if I was going to change that to standard form, what would I need to move? Well, just that 5x term. It needs to go on the other side of y. And when I cross the equal sign, I just need to remember to make it a negative 5x. Just change its sign. So finish copying the rest of the problem. That was the only term that you really needed to move there. Negative 5x plus y, so it keeps its sign, equals 6. Now, for the sake of solving the rest of the problem, even though we're not converting the top equation, I would go ahead and still write it out over top. So recopy it again. You'll see why in just a minute. The second step to solving systems by equation is to eliminate zero pairs. But if there are none, then you need to make some. So let's go over again what a zero pair is. A zero pair is when you have two numbers that are the same, but they have opposite signs. Two numbers that are the same, but with opposite signs. So I'm going to show you some examples of this step. Actually, 3 of them altogether, so I can show you all 3 scenarios. Here I have example 1. Example 1. 2x plus 3y is equal to 4, and 4x minus 3y is equal to 2. Oops. There we go. Oh, let me get this. There you go. It's being a little touchy. Okay, so you have two equations. 2x plus 3y equals 4, and 4x minus 3y equals 2. Now, when you're using your elimination method, you're trying to eliminate zero pairs. You're trying to eliminate a variable term, not the constants. So you're not paying attention to that 4 and 2 there after the equal sign. You're looking at your x terms and your y terms and their coefficients. So look in front of the coefficients. The coefficient of x is 2 and 4. Those are not the same numbers, and they're also not the opposite signs. The coefficients of y are positive 3 and negative 3. So notice how those are the same number but opposite signs. So they would eliminate. They could create that zero pair. Another example. Think of each one of these examples kind of like scenarios. So in example 2, we have 2x plus 3y equals 4 and 5x minus 6y equals 7. Again, we're trying to eliminate zero pairs. Well, let's look at our x terms. Are those the same numbers but opposite signs? No, they're not the same numbers, nor are they opposite signs. Let's look at your y terms. Those are also not the same numbers, but they are the opposite signs. So if you ever have two equations that do not already have zero pairs, then you need to make some. And when you make them, I would look for, if it's halfway there. For example, the 3y and the 6y. Even though those are not the same numbers, they are already opposite signs. So let's try to eliminate that y term. When you eliminate or try to convert it so that try to make zero pairs, a method that I know that works every single time. There are other methods that might be shortcuts, but they don't work all the time. So I like teaching and showing everybody the way that works all the time, and that way you have less to remember. So what you will do is multiply, and this is, again, it's the scenario when you have opposite signs but you don't have the same numbers. So what we're going to do is we're going to change both of these equations. The way you change them is you multiply by their opposite coefficient. Just the number part, not the sign. That's important. So the coefficient of the top equation's y is 3. So what you'll do is you'll multiply the bottom equation by the same 3. The second equation, its coefficient, just the number part, not the sign, is 6. So I'm going to multiply the top equation by 6. So the whole equation, you will multiply, kind of like the distributive property, every single term, both before and after the equal sign, by those numbers. So you will write, and I started writing on this, so now I'm going to mess myself up. 6 times, oops, sorry. Okay, there we go. It's going to look a little doubled for a second here because I already did it once. So 6 times the 2x is 12x. 6 times the 3y is positive 18y, and 6 times 4 is positive 24. But the 3 times the 5x is 15x, 3 times negative 6y is negative 18x, and 3 times, ooh, I made a mistake there. That's supposed to be 3 times 7 equals 21. Okay, now that I have, do you see there on front of the y terms, the coefficients are the same but opposite signs, so they can eliminate now. And example 3, or scenario type 3. Alright, oops. Get this for you. Okay. In scenario 3, or example 3, there we have x plus 2y equals 3 and x plus 3y equals 2. Once again, look at the coefficients. Well, we got x and x. What are those coefficients? Well, if you don't see them, remember that those are 1s. Okay. And 2y and 3y, those are the other coefficients. So once again, we do not have the ideal situation to make a zero pair. Our x terms, those are the same numbers, but they're not the opposite signs, and our y terms are not the same numbers or the opposite signs. So when you're eliminating, again, look for the terms that are at least halfway there. So let's look at the x's, seeing how the numbers on the x's are the same, but they're just not opposite signs. So to convert those, or to change it so that one of them is an opposite sign, all you would need to do is multiply one equation by a negative, or -1. So we'll distribute that out, and you'll get negative x minus 3y is equal to -2. Once again, though, because we're not really changing anything on the top equation, you will simply just rewrite it. Let's copy it down. Oops. So there, I just copied it down. Now look at our coefficients. On our top we have an x, and on our bottom we have a -x. The coefficients are both 1. If you don't see it, remember it's just 1. Therefore, they both can be eliminated. And I made a mistake there on the end, so that's supposed to be a... Oh no, that's supposed to be a -2. Okay. One last situation, of course, would be if they're all the different numbers and all the same signs. Then again, you would just multiply by the opposite coefficient, but make one of them a negative. So I guess you do need an example. Just a second. Okay, so here's your example 4, and this is that scenario I was telling you about. X plus 2y equals 3, and 4x plus 5y equals 6. In both of those equations, none of the coefficients are the same, nor are they opposite signs. So what you will do is you'll want to eliminate one of the variables. It really does not matter which one you use, but I would always pick the variable that has the smaller coefficients. And so that would be the 4 and the, what's the coefficient of that other one again? 1. Okay, so we know we need to do kind of the same thing we did in example 2 and 3. We're just going to combine it. So remember from example 2, what we do is we multiply by the opposite coefficients. So I'm going to multiply this equation by 1 and this equation by 4. And then I also use the principle from example 3, whereas to change their sign, I need to make one of those a negative. So I'm going to make that bottom one a negative. And then you just multiply it through. Sorry, I thought I had my white pen tool back. So 4 times x is just 4x. 4 times positive 2y is positive 8y. Is equal to 4 times 3 is 12. In the bottom of the equation, 1 times 4x is negative 4x. Negative 1 times 5y is negative 5y, which is equal to negative 6. Okay, so we kind of did both there, and now look at your coefficients. Which one is the same number but opposite signs? Well, those would be the x terms, so those eliminate. The third step in solving this system is to combine like terms. And remember, when you're combining like terms, you use that SOB rule. So here's an example. Oops. I'll get us there in just a second. Okay, so far you're at this point. You see that we have, you've crossed off a variable that you've found a zero pair for, and now you're ready to combine. So you just look vertically. We have 2x over 4x. Are those the same signs or opposite signs? Well, they're the same, so therefore you add, and you'll get 6x equals, and then you should have 6, because 4 and 2 are also the same signs, you add them together. After you get to this point, the equation should look really, really familiar, and you can just solve for that one variable. You're not done after this, but you can solve it. I'm going to show that solution and talk it out with you. There we go. So it was 6x equals 6 when we combined our like terms, but now we're ready to solve, and we see that there's an 6 beside the x, so if it's beside it, we have to divide it, right? So x is equal to -1. Don't forget there are two variables though. So we are not done with this problem. Unfortunately, right? Okay, so how do we find out what y is equal to? Because now we know what the x is, remember that our final answer is going to be a point or an ordered pair, just like they were when we graphed them and we were looking for where they intersect, because this is the point of intersection without in the graph. So we know our x value is equal to 1. Our next step is to plug it in into an original equation, like before you changed them. Alright, so I have a problem. I have the two equations here. Let's pretend I didn't change them, otherwise I'd have to look back a little further. And you can pick either one of these equations. It does not matter which one. I'm going to go ahead and just pick the top one. Oops, change my pen tool. So 2x plus 3y is equal to 4. Well, we now know what x is equal to. It's equal to 1. So we can replace or plug in that 1 for x. So plug it in. Plus 3y is equal to 4. And then, of course, you have to then solve. Solve for that y. So we need to multiply these two numbers together. Get 3 plus 3y is equal to 4. You are trying to solve for y or get y by itself. So we have two 3's here. The first 3 you need to move is the 3 that's being added. So that's the same thing as saying 3y is equal to 4 minus 3, because you have to subtract it. Or just 3y is equal to 1. Final step then, you would have to divide by 3. Divide by 3, sorry for going off the page there. So y is equal to then 1/3. I just made these numbers up off my head. I wasn't sure how they were going to work, but that is still an answer. You can have a fraction, but we just won't see it that often. So y equals 1/3. Alright, let's practice some of these on some of your problems that you have on your page. So you can turn your paper over now. Let's look at some. Okay, so let's take a look at problem number 1. Do we have a zero pair already? Look at your x terms. We have a negative x and a positive x. The coefficients are 1, so yeah, we can eliminate them. So we did step 1. We eliminated our variable. Step 2, combine. Oh, I guess actually step 1 is to make sure that they're both in the same form. And they are. They were both in standard form. Step 2, we eliminate the zero pair. If there are none, then you change to make some. We didn't have to do that here. Now we're ready to combine our like terms and solve for one of the variables. We have a negative and a negative 2y and a negative 8y. Those are the same signs, so you have to add 10y, but the bigger sign wins, which is negative. Equals negative 1 and negative 9 equals negative 10. And you have to then solve for that one variable. Well, we have a negative 10 that you need to divide both sides by. So y is equal to then negative 10 over negative 10 is just 1. That's part of your answer. Oops, and be careful. Oh, I'm glad this came up here. When you are doing your elimination, you may not always get the x variable first. Remember that your ordered pair is a coordinate with an x and a y value. So, a very common mistake, like I was just about ready to make, is that I was about ready to put that 1 where the x goes. So your answer for the 1 comes over here. Now we need to go to the next step, where it's plug it into one of the original equations. Change my pen color so you're ready to see this. So look at your two equations. I would pick ones, if I had to choose one that had smaller numbers, not a lot of negatives. I'm so sorry, didn't mean to yawn. Not a lot of negatives. So I would probably choose that one, but it doesn't really matter. The original equation is x minus 8y equals negative 9. So I substitute the y this time because I know what y is equal to with that positive 1. So x minus 8, plug it in. So yes, it will change between x and y. It just depends on which one eliminates first. And then you need to multiply those two together. So you get x negative times the positive is being negative 8 equals negative 9. And then add the 8 to both sides to eventually get your x all by itself as well. And you get negative 1. So that is your x1. Okay? Sorry, I didn't mean to flash it back and forth on you. Alright, look at scenario 2. Or problem number 2, I'm sorry. So do we have, are both of our equations in standard form? Yes, they are. Good. Do we have a coefficient or a term that has the same number, same coefficient, but opposite signs? We sure do. The 3's. Oops, I'm going to change that color. I must have hit something because it started a whole new recording on me here. I'll see if I can merge the two together. Yeah, otherwise I'll put the recordings back to back and you're watching the second show now. Okay, so one method that you can use when you're solving these problems, because it might be overwhelming to you to think, oh gosh, I've got all these steps to do. Well, if you know you have to do those same 4 steps to all problems, what you could do is actually do that one step to all the problems on the page, and then go back and do the second step to all the problems, then the third steps. I find this able so that you can concentrate on just one task at a time, and you're less likely to make mistakes. It's a great testing technique. So if I know that all my equations need to be either both in standard form or in slope-intercept form. So let's just identify all the problems on this page. Actually, because I can only get problems 1 through 6 on this current screen, let's just look at those first 6, and I'll let you do the bottom problems. I think there's 4 more completely on your own, and then you can check them. So let's look at the 6 as our guided practice. Are there any one of those 6 problems where we need to rearrange some equations so that they're both in the same form? You find it? There's only one. Problem number 6. If you're just looking at problems 1 through 6. Just draw a line there so you know that we're just looking at the first 6 problems. Yeah, problem number 6, the equations are not both in the same form. So let's write them in the same form. Again, most people like to use them in standard form, so we're just going to write both these equations in standard form. Standard form says you write your x term first, then your y term, and equaling your constant. Now, why didn't I change those signs on that 10x and 4y? It looked like I moved them to me. Normally you move them, don't you change the sign? Why didn't I do that? Think about it. We only change the sign when you move a term across an equal sign. Did we ever cross the equal sign with either one of those terms? No. So their signs don't change. We just put them in a different order, and that's okay. All right, next equation then that you need to change. Put it in a different order. We put it in standard form. Now in this case, that 2x and that 4y both need to go across the equal sign. So if we move them across the equal sign, we have negative 2x and negative 4y. You had to change the signs on both of them. Is equal to, what would you write? Negative 18. That one does not change its sign because we didn't really move it across the equal sign. It just stayed on the right-hand side of the equation. So do we have any zero pairs? Yes, we do. That makes it nice and easy now. So you've done step 1 and step 2. Step 1, make sure that they're in the, we didn't do step 2 yet. So step 1 to all the problem was just if it's You need to get both equations in the same form. Step 2, eliminate any zero pairs. So let's look at problem number 3. Do we have any zero pairs? Yeah, you do. Problem number 4, do we have any zero pairs? Yes, we do. These are nice. Problem number 5, it looks kind of funny. It makes you think that they're not both in the same form, but they are. Do we have any zero pairs? Sure you do. Do you see it? The negative y and the positive y? So cross them out. You might on the lower 4 problems, or it might be on another practice page. We might be dividing it up, or the teacher might be giving you a different little bit of practice at a time for the next skill up. So none of these did we have to ever make some terms be the same coefficient but opposite signs. Alright, so our next step is to combine and solve, right? So let's combine these. But you get 7 and negative 6 is just 1y is equal to negative 26 minus 18. What is that, 18? But it's a negative 18, isn't it? Because the 26 is bigger. Oh, that's not right. Hold on. It's negative 8. Okay. You're doing math and I can't seem to do it right now. Okay, to look at problem number 3, let's do the same step on all these problems here. We're just combining our like terms together. 9x and negative x, those are opposite signs, so you subtract. 9 minus what? Well, what is it? Remember the 1? So 8x, and it stays positive because the 9 is positive. 21 minus 5. 16. Now this one it's not all by itself yet, so we do need to solve it. Divide by 8, divide by 8. So x is equal to 2 on that one. Look at number 4. Combine them. 6x and 10x is 16x is equal to, look at that, 21 that's negative and a 21 that's positive. That's a zero pair as well, but it doesn't go away completely. You do need to write a 0 in. Next one, you have a positive 3 and a negative 7, so you should get a negative 4x is equal to negative 17 and positive 5. Again, you'd have to subtract. It would be a negative 2, right? No, 9. No. Yeah. No. Sorry, it's late, as you can tell from my yawning. Okay, it's negative 12. Get that get that x all by itself, so we divide by negative 4, divide by negative 4. So x is equal to negative 12 over negative 4. That would be a positive then 3. Problem 6. We have a 10x and a negative 2x. That would equal then positive 6x is equal to negative 6 and negative 18. Can you do it? Go ahead and you try it and write it down. Well, they're the same sign, so you have to add, right? 6 and 18 is 24, and the bigger sign wins. They're both negative, so it has to be a negative 24. To get x all by itself, then you'd have to divide by 6, divide by 6. So x in this one is equal to 4. Alright, so we're halfway there on all these problems. Again, if there's not enough room to do the problems on the page, feel free to work them on a separate sheet of paper. Just attach it when you're done. So what I would probably do, because I know that these are all supposed to be coordinates, somewhere maybe out of the way but near the problem, so whoever's grading it knows where your answer is at. I would make the ordered pairs and get them ready. So problem number 2, that's y is equal to negative 8. So we could write it on the left or the right. Negative 8 is on the right. Number 3, x is equal to, so that's where the x would go on the left. Oh, I drew too many over here. Oh, and I didn't finish solving that last one there, or problem number 4. Let's finish solving that one. We have 16y equals 0. We're not done because y is not by itself. So we divide by 16, divide by 16. That means that y is equal to 0 on that problem. So y is 0. It does matter which side you put it on in that comma. X is equal to 3. And on this one, I remember going up above here, was it the 4? X is equal to 4. Alright, you're halfway there on all those problems. Now you need to plug it into one of the original equations. Because I have a limited screen area too, I'm just going to have to erase this original work. So if you need to finish writing or copying something down, then push pause and finish writing and copying it down. I do not want you to erase on your page. If you have to, rewrite it on a separate sheet of paper so that you can see all your steps, if you're realizing that there's really not enough room to do the whole problem in the space that's provided. Alright, I erased one, but I'm realizing that we had already solved that one completely. Problem number 2, we have y is equal to negative 8. Take one of those equations and plug in that negative 8. I'm going to use the bottom one. 3x, but it doesn't matter which one, you should get the same answer when you're all said and done. So I'd have to multiply these two together. I'm going to also make sure when I multiply, I include that sign in front of it. So 3x, a negative times a negative is a positive. 48 equals 18. Now solve, get x all by itself. Bring over the 48 as a minus 48. I have to write it off to the side there. So you get 3x is equal to 18 minus 48. Should get a negative number. They're opposite signs, and the bigger sign is 48. So 48 minus 18 equals 30. But it's a negative 30. And then you divide both sides by 3. So your x value then is equal to negative 10. Sorry if you cannot see that right now. So negative 10. And yeah, my handwriting on this, it is not easy to write a stylus, so don't think that that's my best handwriting because the stylus doesn't make it so. You're ready for problem 3? If not, push pause, keep working on it, and let's come back to it. So in problem number 3, again, you need to plug your variable that you just solved for into one of the original equations. I'm going to choose the second one, just because the numbers are small. So we have x, or negative x, and we already know what x is, it's 2. So you can put negative 2 minus 3y equals negative 5. This negative 2 can be put on the other side of the equation by adding 2 to both sides of the equation. So therefore you have negative 3y is equal to negative 5 plus 2, those are opposite signs, so you have to subtract, equals 3, but the 5 is bigger, so that's a negative 3. And then divide both sides by negative 3. Y is equal then to positive 1. Question number 4. I have a 0 to plug in for or replace the y with. I'm going to choose the top equation because it has smaller numbers. 6x minus 3y, but y is equal to 0, equals negative 21. 0 times negative 3 will cancel that whole thing out there. It'll just equal 0, so you have 6x is equal to negative 21. And then you'd have to divide both sides by 6. You're going to get a fraction or a decimal for this answer. So your x, therefore, then equals negative 21 and 6 can both be divided by 3. So it'd be 7/2. Seven over 2. Oh, and it's negative 7 over 2. Question number 5. I know what x is, it's 3, so I'm going to plug it in, and I'm going to use that top equation. 3 times 3 minus y is equal to 5. 3 times 3 equals 9, minus y equals 5. And then I need to bring that 9 to the other side of the equation. So I would write negative y is equal to 5 minus 9, or negative y is equal to negative 4. Then I need to get rid of that negative in front of my y, so I divide by negative 1 because that has a coefficient of 1. Divide by negative 1, that means my y then is equal to positive 4. And the last one, what happened here? Okay, it looks like we already had solved that one, so we were done with that one. Alright, try the next 4 problems on your own. I'm not going to narrate those 4 problems, but I will work out the problems, and when you're ready to check yourself, then just push play and you can see all the answers. Alright, problem number 7. The first step, we had to rearrange the equations so that they were both in standard form. Then we looked at our coefficients and noticed that, well, none of them are the same but opposite signs. But yes, the y's were already opposite signs, so we're halfway there. Let's use their coefficients. I multiplied each equation by its opposite coefficient without the sign, because the signs are already correct as they are. Once I've done that, you can follow that in the green. I did each step in a different color so that you can follow me. I noticed that our y terms can be eliminated now, and we combine like terms. After you combine like terms, you're solving for x, and that's how I got that negative 4. And then the last stage of the problem, you have to plug that negative 4 back into one of the original equations. I chose the top one this time. And you can see I substitute that negative 4 for the x in it, and then simplified it all the way down until I got y of positive 2. So your final answer you should have gotten is negative 4, 2. Alright, and problem number 8, let's see. We had to rearrange both equations so that they were in the same form. The top equation, if you notice, I did something a little different than probably what you've seen. What I did is I just flipped everything around, keeping their signs, and then reordered the x and y term. So the signs were able to stay the same, and I'm able to do that as long as I only flip it that one time and arrange it. The second equation, okay, so then I was looking for what variable to eliminate. I noticed that none of my coefficients are the same, but I'm at least halfway there with the y variable, that they're opposite signs already. So I multiplied each equation by its opposite coefficient. The numbers are kind of big, but they reduce very quickly. I did use a calculator on this, and yeah, go ahead and use calculator on these. The y term then eliminates, and I combine my x terms. I combined the constants and divided by 168, so I was able to get that -1 there. I plugged that -1 back into one of the original equations. This time I chose the second equation, again just because they're smaller numbers, and simplified. So I got a y of -3 at the end. So your final answer is -1, -3. Okay, and problem number 9. I had to rearrange both equations again. And this time when I rearranged them, I noticed that I had the x coefficients, the numbers were the same, they just were not opposite signs. So rather than multiplying by opposite coefficients, I just multiplied one of those equations by a -1 or by a negative to change all the signs. And I just realized I made a mistake. So, yeah, I made a mistake. So hold on just a second, let me back this up. Okay, I backed that up. What I had noticed is that I didn't change all the signs when I multiplied by that negative on that second equation. So the 4x turns to a -4x, the y changed to a +y, and the -20 turns to a +20. Then I go and combine like terms. I eliminated that x variable, and I'm left with 4y equals 32, and so I had to divide by 4 to get y of 8. I used that 8 and plugged it back into one of the equations. I chose the first one this time. Didn't really have a preference either way on this one, but I did notice that x was already by itself, and that's what I'm trying to solve for, pretty much by itself. So that's kind of why I chose that one. And I replaced the 8 and simplified, and I got x of -3. The ordered pair then would be -3, 8, not 8, -3, which is what I commonly see students do. They tend to write down the first number that they had solved for without realizing that, yes, x comes before y in an ordered pair. And the final problem. This one was a little bit easier because after you rearrange the equations to get them both into standard form, you notice that the x terms are already same coefficient and opposite signs of that ideal situation that we were looking for. So that's that 0 pair, we eliminate it, and so we don't need to multiply anything to either equation. Combine our like terms,